In this video, we are going to learn how to create and read position versus time graphs for objects moving with uniform motion. We're going to start by analyzing this motion here, which says a ball is rolling with a constant velocity of 1 meters per second to the right. The first thing I want to do is just visualize this motion. So what I'm going to do is draw a number line, and we're going to use this number line to visualize how this ball is moving. Initially, it's right here, and if it is moving with a velocity of 1 meters per second, in 1 second, it will go 1 meter. In 2 seconds, it would go 2 meters. In 3 seconds, it would go 3 meters. And in 4 seconds, it would go 4 meters. And now we're going to graph this motion on this position versus time graph. We're going to start by labeling our axes. So for a position versus time graph, you have time on the x-axis. In this case, the units are seconds. And then you have position on the y-axis. And in this case, the units are meters. I'll then put some numbers on my axes. And now we're ready to plot our motion. The first point is at 0 meters, 0 seconds. And so we'll plot that on our position versus time graph. And then the ball moves to 1 meter after 1 second. So we plot this on our graph. And we keep plotting. We'll be at 2 meters at 2 seconds, 3 meters at 3 seconds, and 4 meters at 4 seconds. And then we can draw a line through our points. And with that, we have our finished position versus time graph. But here are a few key points that we need to know about these graphs. The first is, if the object is moving with a constant velocity, which is what we see here, the position versus time graph will be linear. So what this means is that objects moving with uniform motion have a linear relationship between position and time. Another very important point, probably the most important, is that velocity can be found from the slope of the position versus time graph. What this means is you can use your slope equations, like m is equal to y2 minus y1 divided by x2 minus x1, or your m is equal to rise over run, to find the slope, and once you found the slope, you have the velocity of the motion. So position versus time graphs are great tools for visualizing an object's motion. Let's do this question here to test our understanding of position versus time graphs. We are told that a person walks 4 meters to the right for 2 seconds, then stops for 1 second, before walking 2 meters to the left in 2 seconds. And for each part of this person's motion, we are going to assume they're moving with a constant velocity. So the first thing we always have to do is write our axis labels. We have time on the x-axis and position on the y-axis. And then you always want to put some values onto your graph. Now our graph is ready to plot our points. We always want to plot an initial point, and we are going to say our person was at 0 meters at 0 seconds, and then they walked 4 meters to the right for 2 seconds. So they will be at a time 2 seconds and a position of 4 meters. The person then stops for 1 second. So time increases. We are now at a time 3 seconds, but the position stays the same. The person's position didn't change because they didn't move. We are then told that the person walks for 2 meters to the left in 2 seconds. So if we were moving to the right and our position was increasing, when we move to the left, our position will decrease. So we will be at a time 5 seconds and a position 2 meters. If you have trouble visualizing this motion, let's draw a little number line. We had a person that made it to 4 meters by moving to the right. That took 2 seconds. We then stopped for 1 second, but we didn't move, our position didn't change. And then finally, the person turned around and started moving to the left. And they moved 2 meters in 2 seconds, so their final position was 2 meters. Once you understand this motion and you have all your points plotted, we can draw a line connecting our points. And now we have our position versus time graph for this person's motion. What I want to do is I want to calculate the velocity of this person's motion. So we have an initial motion where the person was walking 4 meters to the right. I will call this V1. Then we have the period of time where they stopped. I will call this V2. And then we have the period of time where they were walking to the left. We will call this v3. Remember that velocity is equal to the slope of these lines. So if we're trying to find v1, we just need to use the slope equations to find the slope. I will use m is equal to rise over run. Our rise is 4 meters, and our run is 2 seconds. When we do the math, this tells us that v1 was 2 meters per second. Now we want to find v2. We can see that this is a horizontal line, so the slope is equal to 0, which means v2 is equal to 0 meters per second. This makes sense. The person was stopped. They weren't moving, so they have no velocity. Now we want to find v3. I could use rise over run again, but just to show a different example, I'll use the m is equal to y2 minus y1 over x2 minus x1 equation. In order to solve for slope, we just need to identify what are our variables. If we look at our graph, we can see that y2 is equal to 2 meters and x2 is equal to 5 seconds. We also have y1, which is equal to 4 meters, and we have x1, which is equal to 3 seconds. We can plug these numbers into our equation and solve for the slope. When we do the math, we can see that v3 is equal to negative 1 meters per second. Now you might be wondering, why is this answer negative? Does that make sense? Well, we know the person was moving to the left, and since velocity is a vector, the negative sign tells us that their direction was to the left. Because remember, velocity to the right is positive and velocity to the left is negative. This explains why v1, where the person was moving to the right, is positive, and v3, when the person was moving to the left, is negative. If you understood how we solved this question, then you have a pretty good understanding of how we can use position versus time graphs to describe uniform motion. However, before we go, let's do a quick summary of position versus time graphs. So we know that a position versus time graph is made when you plot time on the x-axis and position on the y-axis. And we saw that for motion with a constant velocity, so that's uniform motion, the graph will be linear because there is a linear relationship between position and time. We also learned that if you find the slope of a position versus time graph, you've determined the velocity of the motion. We also learned that objects that are moving to the right will have a positive slope, so the velocity will be a positive answer. And that would look like this graph right here. Then we learned that objects moving to the left will have a negative slope, and the velocity should be a negative answer. And we can visualize this as a graph that is decreasing. Finally, we saw that if the object is not moving at all, the slope will be 0, and your velocity will also be 0. On a position versus time graph, this would look like a straight horizontal line. Now, one last note. We looked at graphs that all have straight lines, so linear relationships between position and time. This occurs when you're moving with constant velocity. But if you don't see a straight line, so you don't see a linear relationship, maybe your graph looks something like this, then you know the object is not moving with a constant velocity. We will see more position versus time graphs that look like this when we start talking about motion with acceleration.